And we're going to start today with this new course called Getting Started in OpenSees with STKO. I'm going to just wait for a few more people to come in. Feel free to open your cameras if you want during the presentation, and we'll have a Q&A session at the end where you can open your mics and just ask us questions directly. Can you guys also see my screen?
Yes.
Yes.
Great. So let's see. There's just one extra person coming in. I think we can start. Okay, so welcome to this new course. We're going to start together from scratch, learning OpenSees with STKO. This course is going to be made of 20 classes. Each class has a 30 minutes presentation given by me. And at the end of it, as I said, I'll ask you to open up your cameras and ask us questions. There's going to be me, but there's also going to be Dr. Petracca joining me and also Professor Kamata. At the end of each class, I will have prepared some assignments for you that you can decide to do or not to do. But the cool thing is that we have a new open thread of our forum for every week, in which you guys can, firstly, if you want, introduce yourself. There's a bit of a lag. Today, only Hannah introduced herself for now, but I'm going to do it too. So if you want, please join too. And in this forum, we'll discuss about the assignments and provide solutions before the next webinar. So just to give you an overview to what we're going to learn in this course, we're going to start with a little bit of introduction, and then I'm going to just whet your appetite by showing you how to define a model in OpenSees with STKO, a full one of a large frame structure. And then we're going to tackle all of these topics one by one: geometries, physical properties, element properties. Let's say these are theory classes, not really in the sense of like FEM theory, but OpenSees theory. So we're going to go through each of these elements and knuckle down what is it that everything means. And at the end, we're going to just dive into instead more specific topics like analysis and full models of referred to concrete and masonry. So what are we going to do today? Today is just a very quick introduction. I'm going to give you information about what is OpenSees, why is it interesting, or let's say why is it super cool, how does it work, and hands-on, so how to install it on your computer, which are the basics of the typical programming language, how are OpenSees commands, how is the notation of OpenSees commands, a little example, some assignments, and all the resources where you can find more information to go on with your learning. So let's say OpenSees, Open System for Earthquake Engineering Simulation. You can find this definition on the internet. It's a bit, let's say, hard to digest. I mean, you cannot even say it all without breathing. So I'm just gonna try to break it down for you. OpenSees is open source, which means that its source code is available for everyone to see. So if you click on the link on this presentation, you can go online and see that, unfortunately, there's a little bit of a lag. I wish there wasn't. Anyway, if you go on the site, you will see that the source code in C++ is available for everyone to use and browse and, let's say, learn and see what it is inside of it. It's an object-oriented, so it's written in C++, as I said. And I don't know if you guys have any previous programming experience or knowledge, but C++ is a compiled language. So it's differently from interpreted languages. It does not execute your instruction as you command them to it. It's a software framework. It's not a software. It's, let's say, it's a compilation of tools that allows you to create finite element applications. These applications are made of the modules inside of the framework, and these modules are interchangeable and extendable. which means that you can create different elements from the ones that already exist, and you can move around the pieces of the puzzles from the ones that already exist. But there's still a problem with it in understanding the definition. So this software framework, it's written in a compiled language. There's no graphic user interface, so how do I use it? The way to use it is through an interpreter. OpenSees is used through an interpreter language, which is STKO. It has also been implemented in Python, but for now we're going to just show you how to do it with STKO. So let's say the interpreters have been extended to include all OpenSees commands. And of course, this is used to make earthquake engineering simulation and encompasses both structural and geotechnical engineering. This part I can say with breathing. The objective, OpenSees was developed by the peer organization in Berkeley at the end of the 90s. And its objective was to share and educate students, but also to disseminate academic knowledge in the industry. The main problem that they wanted to face was the idea of trying to exploit computing technology fully and being able to experiment fully with computing technology in FEM applications. But the traditional code for finite elements does not allow the user to actually go inside and being able to use and change the code at will. So they kind of went full technicolors and created a framework of components in which the users have access to each of the elements of the code. The code is not closed, is not static, but is accessible. And let's say the user is not anymore just someone that clicks on an interface and define what is already predefined inside. The computation technology is not embedded in the software, but it's in your hands. We've made a little survey before this webinar. Of course, I mean, most of the answers arrived a bit late, so I didn't have the time to compute all of them. But as you can see here, these are the softwares that you guys told me that you normally use. So most of these, none of you guys uses the software in the first range of this graph. Let's say these are softwares that are used by professionals on an everyday basis just to make linear analysis and automatic checks against the code. Most of the software that you use are, let's say, the ones used by professionals for basic research, and the one at the bottom of this graph, the one really that are high level and are made to do nonlinear analysis and using very refined and sophisticated mesh algorithms. But as you can see from this graph, all of these software have a black box. So you cannot really go inside and see what is happening. OpenSees positions itself in a different way in respect to all of these other softwares because it is open box, first, and second, it is open source. And it has full scripting capabilities. One thing that really still is not the best from the previous definition that I gave you is that it does not have an interface that you can use to visualize what you're modeling, and it doesn't have mesh algorithms for you to implement. But let's say this is a sneak peek on our next class, because in the next class we're going to talk about STKO. But with STKO and OpenSees, you kind of beat everybody else. So what is the potential of OpenSees? Here on the bottom, I'm just going to show you a few of the applications that we've done here in ASTEA. But today we're just going to learn how to make a very simple model. So all of this stuff is going to still seem to you like space science. But just so you know, with OpenSees you can do really a lot of stuff. You can program automations and build large buildings with a very few lines of codes. You can operate parametric analysis. You can integrate structural checks from building codes inside of your software without having to copy paste from other parts all the time. You can exploit full computational capabilities for detailed design, like the one that you can see at the bottom center. And you can add new components that you code yourself, element formulation, material models, algorithms. Let's say with this kind of software, you have complete control of what you're doing. Rather than just driving your regular car, you are driving a Formula 1 car in this case. So how does it work? As I said, it's a software framework, so it's not an executable. It's made of blocks, in, let's say, modules. In the first module that you find in OpenSees is the model builder. The model builder constructs objects. These objects are added to the second module, which is the domain, that stores these objects inside of it and provide access to this object to the other modules, which are the analysis and the recorder. The analysis will move the state of your model, of your simulation, from a time to the next time step, given a certain delta, and the domain will hold that state until it's moved. And on top of it all, the recorder will monitor specific parameters that the user defined in such movement, in such simulation. All of these modules have tons of stuff in any of them. So just to give you a little bit of an overview now of how they work. In the domain, you find elements, materials, geometric transformation, everything that describes your geometry, nodes, of course, and everything that describes your kinematic constraints and your boundary conditions. So single point constraint, multiple constraints, dot patterns, time series. Time series are the things that define the time against the load factors and patterns that you are applying in the simulation. So all of these add up to a ton of things, a lot of names and codes, and these are things that for sure you're gonna get, of course. Can you guys hear me better? I've seen on the chat that someone says the mic is not close enough.
It's much better.
Thank you, Onur. Thank you for saying. So you will get acquainted with all of this, I'm sure. The other block, the other module, which is really important, is the analysis one. In it, there are a lot of things. I believe this, for me, at starting was the scariest one, because everything sounds very complicated. And normally this is something that in other FEM software that I've used, it's already being handled much more, let's say, without you understanding, without you knowing. So in the analysis model, there is the constraint handler, which actually handles the constraints that you impose to your model. Numbers the degrees of freedom, the number. There is something that tests the conversion of the solutions. Something that determines the next time step in each analysis. The integrator that iterates from the last time steps to the current time steps, and the solver that provides the solution. Just so you know, each of these elements, it's something that anybody can define a new one and decide to add it to the framework. So this is really the cool part. So just for you, we haven't sent you this before because, of course, with 30 minutes, it's a bit of time tight, but you can try to do this yourself and see if you manage to do it while we are talking. Otherwise, just do it later. There's many ways to install OpenSees on your computer. From our survey, most of your people are going to run it on Windows. So this is the procedure that we suggest. Go on our website, log in, and just download the OpenSees compiled by Professor Nicola Tarque, which is an unofficial version of OpenSees, but it's a perfectly functioning compiled version that we used in support with our STKO, and install it in the default directory. This default directory will be called like this: C OpenSees solvers. In this default directory, you will find 3 BUT files. These 3 BUT files are to run OpenSees in different ways. So first, you can run OpenSees sequentially. Then you can run OpenSees parallelly in 2 ways: single processor or multiprocessor. Both ways will allow you to run your models on more than one processor, but for a single processor, running OpenSees single processor, you will have access only to the first processor. So your your script will be run only on the first one, and there will be an automatic partitioning of your model inside the first processor, and that will redistribute your model on the others. This is very much used for large models. Instead, on a multiprocessor OpenSees, you can define operations to happen on each processor. So you have access to each of them. And this is really useful if you're doing a large number of analyses or if you're doing parametric analysis, for example. So you are running the same model, changing only one parameter. So let's say I'm going to just show you how I do it. Let's say you are here. This is the OpenSees folder that you will find with these 3 files I've been talking to you about. The next thing you have to do is to just go in a file that this is the file I prepared for the folder I prepared for today, and just shift right click and open PowerShell here. If you navigate to the OpenSees folder, and just run OpenSees.bat, now you're in. This is your OpenSees interpreter. So going back to our presentation, in this OpenSees interpreter, what do? We write in TICO. So TICO is a programming language which is based on string. Every command that you write is a string, is computed as a string. There's a lot of operations you can do. The cool thing that I was trying to convey before, I'm not sure if I managed, is that you not only, in the software framework, you not only have all the commands of OpenSees, but you have all the capabilities of the interpreter language too. So you can actually make calculations, iterations. You can use control structures. You can create functions. You can source external file and manipulate files that you create in your simulation. So everything is in your control. In TICO, you have to reference each variable with the $sign. This is something very important to remember. And of course, use this for comments, but this is common to many of the languages. So if we go to the interpreter that I've shown you before, and let's say we open our first support file for today, I can show you a little bit how is it that we can use TICO in the OpenSees interpreter. So just starting from the basic, to display something on your screen, you just use the command put. To set a variable and assign a variable, you use the command set. To make operation and variable evaluations, you use the command express. I'm not going to type it out because it's just going to take too much time. But I'm going to be sending you all of these files, and I invite you to try out and just like type it yourself and see how many mistakes you make only in one go. It's a bit complex to get it right at the first time. Let's say there's a lot of other things that I can show you. So for conditions and loops, we can use if, while, for each, all of these elements. And of course, list manipulation is something really, really useful. We can set, let's say, a list of elements, and then iterate over this list. Iterate over the list and print each element of the list, for example. We can also create functions with the function proc. And each function has a name, an argument, and a body. In the body, you can define what is it that you want the function to do. And the argument is what is it that you're going to call as variables for that function. So let's say I'm going to try and use the function I just created, which is just going to sum these two variables. And it's going to give me the sum of the variable and the product of the variable and print it out. Of course, you can also do file manipulation, setting an ID for the file, and then opening it and writing on it. All of these letters, they mean different things: write only, read only, write and truncate, read and truncate, etc. And of course, at the end of your exercise, you kind of clean out, wipe the memory, and exit. Of course, I can read a question in the chat. Of course, I will give you the technical command. All of these files that I'm going to show you today, they're going to be uploaded tomorrow on our website, and they're going to be free for you to check and experiment with. So coming back to our presentation, I just wanted to show you also here. I'm not going to click on it because there's a bit of a lag, but here you have a site where all the TCOS commands are explained and described, and you can search for something you need that maybe it's not in the basic things I described today. So after, let's say, basics of TCO, we have to see how an OpenSees command is actually built. An OpenSees command is are all made like this ones. These are the first two that you will ever write in your TCO scripts. The first one is the model command. It kind of constructs the model, the model builder in your simulation. So there is the name, basic builder, and number of dimensions of the problem, and number of degrees of freedom at the node. So for this is kind of important to remember, because in TCO, lists are zero-based. So in a list may be made of 3 elements. The first one index is 0, 1, 2. But instead, degrees of freedom and dimension of problem are they are 1-based. So it's 1, 2, 3. In each of these commands, you can find some of the elements in between this kind of notation. This will mean that addition of this element to the command is optional. So you can put it or not. It's not necessary. And the second things you can find is something like this in brackets. So you find a number and a variable. As I said before, variables are identified with the symbol dollar symbol. In this case, you have to introduce the number and the type of values that are required by the command. So now that we know a little bit about TCO basics and we know a little bit about OpenSees commands, there's something really important that you have to remember and never, never, ever forget, is that OpenSees does not have the concept of a unit system. So you have to define it yourself. You have to define it yourself, and you have to keep consistency with it as you model. I've created a script for you guys. It's called utils0. It will be uploaded as everything else on our site. It is something useful that I use and that I advise everybody to use, especially if you're not, let's say the input data that you're trying to put in your model are not all in the same dimension, all in the same units. So you're going to have to make conversions. So instead of doing your conversions on a piece of paper, on a parallel Excel sheet, on a Google that you type in Newton meters to Newton millimeters, instead of doing something like that, I would suggest you to write your own TCO script and source it into your models. This one is based on the international system. You'll just need to define, let's say, your units as your reference unit, and then define the derived unit, the multipliers, all the conversions that you want to implement, and input values in the end directly by multiplying the value that you're using by the unit in which it is defined. So I'm going to just show you now how you can use this kind of script inside of a very, very simple model, a really basic one. We wanted to start with something really that everybody knows by heart. Everybody that has studied structural engineering knows by heart. A fixed beam with a distributed load. Everybody knows how to calculate its response. And so to make this kind of model in OpenSees, you have to write something like this. You have to start your model, your script, by wiping out all the memory from your OpenSees, because this is just something for, let's say, computer hygiene, I would say. You source that file that I've shown you before for the units so that we can use it right away. And you start defining the elements of your model. I haven't shown you in the other slide, but our model has square section of 300 millimeters. This is its elastic modulus. The area is calculated in this formula, and that's the same is for the inertia. And we're going to set the length of the beam to 4 meters. As you can see, I have now used the units conversion that I've taken from the other file. This had allowed me to just like type in a name without having it to, let's say, a variable name, without having to even think about it. Then the first thing that we do, as I've shown you before, is we call the model command. We are defining a basic builder with in two dimensions. Our problem is in 2 dimensions with 3 degrees of freedom. We have 2 nodes. So our beam has 2 nodes, one at the beginning and one at the end. So coordinates of the nodes are 0, 0, and 0L. As you can see, before each command, I've copy-pasted what is given as documentation for each command in OpenSees. This thing, of course, you will be able to find. This I'll have to show you guys because it's really important. So you're gonna just forgive me for the lag. Everything you want to search, you can use the OpenSees documentation. And for example, the node command that I typed before, I can just search for it, and I'm gonna find exactly what I have to type down to use it here. There's description for each element and the type of element, let's say the type that the command expects as variables, as argument, etc. So where were we? Here. Then we have to assign the geometric transformation. I'm not going to explain you here what is a geometric transformation. It's just trying to move the basic coordinate system to the global one. We assign an elastic beam column element to our beam. This I haven't told you before. So each of the things that you define in a STKO script needs to have a tag. The tag is a reference that you need to use because then you can reference the same elements afterwards. When is it that the specific type of element or node, etc., has to be called? We have to define in between which node the element has to be constructed, what is elastic modulus, what is area, what is inertia, and what is geometric transformation. We assign a linear time series. Let's say our load is applied linearly in our simulation, and we fix the first node, so the beginning of the beam, in all of the 3 degrees of freedom. We define a load of minus 1000 Newton. Here I didn't have to use my unit system because I was already in the one that I had defined before. Here, Newton, meters, and kilograms. This is something that I just typed down. It's not something that the software will read. So you have to be careful for it. And then assign a load pattern. Also here, we will go into details of these things during our course. Just so you know, I'm just trying to assign a load pattern which on the element which is distributed. And I refer to the variable that I defined before. For this block, I'm just gonna have to ask you to take it for granted, like a leap of faith for today, because I don't have time to explain you all of these things. I did a little bit before, but this is, let's say, is the basic setup for a linear analysis. We have a linear algorithm because we don't expect anything strange to happen in this model. And then I set up my analysis. I make my analysis start with 1 increment. I will just apply my load all together. What I added at the end of this file is just a little check against the analytical solution of what is it that we know, what is it we know to be the analytical solution for like a fixed beam. So I define what the response analytically here. I sourced the numerical values from the response of my model. And then I defined an error expression and I will print out on my screen which is the value that I obtain analytically, numerically, and the error that I obtain between the two. I will raise, let's say, not an error, but I will print out the verification if it's okay or not, whenever this error is below a certain threshold. I will show you how to run this file now. I go into my folder. Actually, I'm already into my folder, but I'm gonna do it again for you guys. I will open PowerShell from here, source my OpenSees, and just run the file with the name that I assigned to it. As you can see, it printed out what I asked it to. I did my static analysis, I checked the shear and the moment, and obtained errors with 0%. Of course, this is a very simple model, so I cannot obtain errors here. And I get a good result here. There's a bug I found. Moment, okay, and moment not verified. There you go. So this is how you can run a very simple model. I also made another example of a portal frame, but I will not show it to you now because we're running out of my 30 minutes. What is it that I can ask you to do on our forum and discuss it on our forum is to choose for yourself a model which is analytical, an exercise which is analytical. I can provide you with some here. I just put them here so you can take them from the presentation if you want, and try to build your own in OpenSees and set up your unit system, source it an external file, and check the numerical solution against the one given by these kind of books. I'm sure you will have from all over the world, so it would be even nice to share them around. And this is something that I think it's very easy to start with on our first week that you use OpenSees. And that's it for me for today. You have this whole list of references and resources that you can click and find. I suggest you to sign up for the Facebook group and also for the OpenSees support group. They make monthly or bi-monthly, I'm not sure, meetings in which they invite people that describe the different things of OpenSees. So thank you guys for listening. And now there's a lot of questions in the chat, so we can tackle them together with Massimo, who came here to help me. Feel free to open your cameras, please. So we really want to see you all, guys. I'm just crystal blue. Oh, it was no. So is there someone that wants to ask a question not from the chat, or we can start from the chat?
I think we can start from the chat and then we go on.
Okay. Well, yes, this I already answered. This we already answered. In today's presentation. Would you like to have, no, this is Guido. When there is more than one element, do we need to transform all the local coordinates to the global one with rotational matrices?
Well, actually, you don't need to do it. The geometric transformation, actually, when you build your model is in global coordinates because you define the nodes in global coordinates, okay? Then what you need to provide for elements is the geometric transformation, but you don't need to provide rotation matrices. You just provide the vector in the XZ plane of the geometric transformation, and that will be used by OpenSees to align the local X and Z coordinate system of the cross section along the element. Okay, so actually transformation of the element from the local system to the global system is done by OpenSees when it does the calculation. Okay, so it's not something that you need to do
by hand.
So, yeah, you don't need to do it. Then there is Nico. Do you have an academic license in STKO? Yes, actually, yeah, we have there is a free license where you have some limitation in the number of nodes and so on for personal uses. Then you have educational licenses For example, if you are a PhD, if you're a professor, if you want to use it for research purposes. And then there are also commercial licenses.
Then there is this one, role of zero length in OpenSees.
Okay, role of zero length. Well, actually, the zero length element is nothing but a series of springs, okay? So a spring is something that relates just 1 degree of freedom of a node to the same degree of freedom of another node. A zero length element can have up to 6 degrees of freedom. So it's nothing but a connection of springs. Mostly people use it for people doing frame models. They often use it for creating rotational lump plasticity models, okay? Where basically the nonlinear rotational behavior is lumped into a spring, and that spring is represented by a zero length element. But you can use it for many other things. If you want just to create springs, or for example, springs for Winkler soil, or if you want to create contact between two bodies. So every time you want to connect a node to another without a geometry, because you don't have a distance between the nodes, so you have a zero distance, there you can use the zero length.
For this one, I think I can answer. I'm gonna just share my screen again to make a little exercise out of it.
Oh,
so, yeah. The question was, why did the numbers are typed 4
with a point, yeah.
And 12 points. So like, let's say, for example, you want to set a variable x with an expression which divides x between two numbers. So let's say you divide 2 by 3. No, not right. What is that doing wrong?
No, you're not inside OpenSees, that's why.
Ah, okay, for sure.
Go inside OpenSees, so you're in TICO.
Okay, now I'm in my interpreter. So let's say in TICO I want to set a variable x as an expression like this one.
2 over 3.
I don't have the answer that I was expecting. But if I define these numbers as floating points, I will obtain a different number. So in programming, you have different types for the numbers that you're inputting. There's integers and there's floating points. If you divide integer by integer, you will obtain
an exact division.
So
a division, yeah, without the rest of the floating point numbers. The problem of TICO is that I don't know if you have some expertise in programming, but there are several different kinds of programming languages. Now TICO is one of them, but there are programming languages like C++, where you basically define the type of a variable. So if you define a variable to be a double, so a floating point number, even if you don't put the 0, the compiler knows that it is a floating point number, so it will do a floating number division. But in TICO, everything is a string. So TICO does not understand what kind of variable it is. So it looks from the string. If there is no point, or there is nothing after the point, it doesn't know that that will be a floating point number. So it takes it as an integer, so an integral number. So the only way you have to tell TICO that 4, for example, is not an integer, but is a floating point number, is to put a dot or something after the dot, okay? That's the only way TICO can understand that you are using a floating point number, not just an integer.
So we have another question about that in this introduction it was used to frame elements. Is it possible to create other kind of elements? What do you mean as kind of elements? Fernandez?
Of course, there are many kind of elements in OpenSees. Frame elements are the easiest one to use.
Yeah.
Yeah, of course you can use solid shells. Since this one is the very first presentation of this webinar series, we assume that you don't have so many expertise in OpenSees. So starting with frames is the easiest way to learn OpenSees. Then you can move to more complicated elements like solids and shells. Also because building a model with a frame can be easy because typically you need just one element for each structural member. But when you use shells or solid, you need to do a discretization. And so it will be easier to do that using user interfaces such as STKO, for example.
And just to set your expectations, so this webinar series, this course is about frame structures. So what we are trying to achieve at the end is for you to be able, after 20 classes, to explore all the things that are in OpenSees, but with the objectives of creating frame models of reinforced concrete and masonry. So like we're not going to tackle shells and solid in this course. But we have many other webinars in which we discuss these topics, and even advanced topics like micromodeling or soil structure interactions that you can check on our website.
Can you tell us something about the Python OpenSees interpreter? Has it the same capabilities of the TCOL interpreter? Yes. There is a basic difference, which is the OpenSees with TCOL is built as an interpreter itself. So you run the executable of OpenSees, and OpenSees will be an extended TCOL interpreter. With OpenSees Python, it's a little bit different, because then it will be created as a Python extension. So you have to open your Python interpreter and import the OpenSees Python extension. So except from this difference, now there should be almost no difference between TCOL and Python. The only problem is that the Python OpenSees is newer, so probably there can be some missing features, but 90% of them are the same with TCOL. So there should be no difference. There's another question about what about material regularization? Is this something that you will consider? I think we will consider it in one of the, when we will go to nonlinearities, because when we talk about distributing plasticity, then there is this topic, okay? So we will show what happened when, for example, you change the number of integration points into a force-based element, or when you increase the number of elements into a displacement-based, and when you have strain softening, you will have problem of non-objectivity, so we will cover that topic, of course.
I want to just ask to the people that came in very late. I've seen, as I was talking, I saw people coming in even after 20 minutes, and I know this was a very short presentation, but if you want, yes, of course, you can say something. Okay, I just wanted to say, for anybody who came in late, if you want me to go back to some of the previous slides, we can do that. Like, we have the time. We set the time aside for, let's say, recapping and asking questions and interacting with you guys. There was Professor Kamada who wanted to talk.
Oh, I just wanted to say that this is not how Francesca thought this course, how we thought this course was an interactive course. So it's not a webinar. It's different from, for example, from what Massimo is teaching. It's going to be a course, so complete course, and we would like you to be interactive, to participate as much as possible, to discuss with us, to give ideas, to let us know what you want to learn. Because at the end, basically, you are going to learn how to use OpenSees, so you don't have to worry that we are going to teach frame elements. With STKO, it's going to be very easy then to expand it to shell or solids to make way more complicated models. What is important is to understand the concept from the beginning to the end. So the structure is what we want you to learn. So to know all the details of how the software is conceived. Then you can become a pro until the end. It's just, to have, so the idea is you to participate to all the classes and to participate also actively with us, right?
To answer to Nizar's question in the chat, yes, today's lecture was only about an introduction to what is OpenSees, how does it work, and how you can just build simple exercises with it. And next time we're going to talk about STKO and like what you can do with it, and like just give the same introduction, but focusing on STKO.
Yeah, because one thing that you have to understand is that STKO is a user interface for OpenSees. But you don't have to think that if you don't know how OpenSees works with STKO, you can do it. I mean, if you don't know anything about OpenSees, you will not be able to use STKO. So STKO is going to improve your modeling. It will speed up your modeling. But if you don't know anything about OpenSees, STKO will be almost useless because you don't know how the solver works. Okay. So being STKO an interface to OpenSees, you need to know at least the basics of OpenSees. and understand all the main components of OpenSees. That's why we wanted to make a brief introduction on OpenSees and then move to STKO and do a parallelism between pure OpenSees and STKO. Okay. So always keep in mind that you need to know something about OpenSees. Otherwise, you will have troubles when you are going to set up all the components. For example, in the analysis, you have seen that the analysis has many components. And if you don't know OpenSees, you may ask, why are you asking me for constraint handler? What is the numbering? There are certain parts in STKO that are really tied to OpenSees. So you need to understand at least the basics of OpenSees.
So I've seen there's like 5 cameras on out of 88. So guys, if you...
And there were 200 people sign up, and only 90 showed up. So it's still a lot of people.
Almost 50%, that's very good. That's really good. I'm very happy with it. I did not expect so much participation, so thank you for coming. Please, if you do have any other questions, even something that I'm sure most of you have already been doing something in OpenSees, been doing something in STKO, something that came up in your modeling, in your...
Yeah, if you have some doubts, some issues, something...
Even if it's not related to the introduction.
Yeah. We have some more minutes to discuss.
So I have a question about license. If I use OpenSees as a base for another app or create an extension for researchers, problem will arise with the license?
Okay, so, well, license is a large topic. So I can tell you something about the license of OpenSees, but if you really need to know what you can do and what you cannot do with the OpenSees license, you would better to contact a lawyer, because you should be managing license is something that is really complicated. So it really depends on what you want to do. Now, in short, OpenSees has an open source license. Now, open source doesn't mean that you are free to do whatever you want. For example, you can download the OpenSees code, you can change it, you can do your own modification, but you cannot redistribute it. So you can, for example, you can use OpenSees for your own job, but if you want, for example, to distribute OpenSees to someone else, you are not allowed to do it unless you are a university or a research entity, or unless you buy a license from the University of California. So it really depends on the scenario. So if you have some doubts, you can ask, but I would suggest you to contact a lawyer for this kind of topic. And every time you need to know something about open source licenses, there are lawyers that deal only with this topic, because it's a very complex topic. Okay. So for example, looking at your question, if I use OpenSees as base for other application or create an extension for researchers, it really depends. For example, when you say you use OpenSees as a base for other application, as we do it, for example, for OpenSees is perfectly for STKO is perfectly legal, because we are not redistributing OpenSees. We just created a user interface that creates the input for OpenSees, reads the input from OpenSees. But for example, you need to have OpenSees on your computer. OpenSees is not distributed with STKO. So doing this kind of extension, if you want to call it, it's fine. But instead, imagine you create a user interface such as STKO and you distribute OpenSees inside STKO, that would be illegal, okay? Unless you are a university, for example, if you are a profit company, for example, like we are, it would be illegal. And there are many other cases. For example, if you change the code of OpenSees, you add your own code, you can redistribute it, but only with the same license of OpenSees, because it is a GPL license. So there are many things. We have another question. I suggest for STKO, it would be useful if we had keyboard shortcuts for commands which are most often employed. For example, fit-all can have the shortcut. There are some of them, yes. Another thing that you can do is to use the command name in the terminal window, because every command has a name. So instead of clicking on the button, you can directly type the name. Not all of them has a shortcut, because actually there are so many commands that not all of them can have a shortcut. But with time, yes, we will consider this.
There was something that Professor Kamal
Oh, yeah.
said about
Professor
Petracca. Hello.
Hello, everybody. Can you listen to me?
Yeah, we can hear you.
Yes. Okay. Thank you very much for such an interesting introduction to OpenSees. Maybe you, not all of you know me. I am a professor at the Pontifical Catholic University of Peru. I work there in the structural engineering division. And I have news because we will launch a course. We will start a course in Spanish about how to use OpenSees and STKO. Maybe it will be around mid-June, end of June. So we will let you know in advance with the starting of this course in Spanish. That is the good news that I have for you, and I hope to see all of you in that course in a few weeks. Thank you very much to all of you.
Thank you, Nicola.
Thank you. Nice to meet you.
Okay, so there are other questions by Pedro. During the lesson, is it possible to talk a bit about how to consider cumulative damage using OpenSees? Of course, we can discuss about it. Are we going to open a forum for this so people can ask and have their requests so that we can look at them and propose them in future lessons?
You've seen that, like we have a week one. I'm just going to show you on this computer. So going online on our website, if you just go on support, I mean, these links are all in the presentation, but also if you just go on support forum, we've created a new section, get started OpenSees with STKO. This is week one. We just have Hannah presentation for now, but exactly, Hannah just posted the link also in the Zoom chat. Thank you, Hannah. And here you can open as many threads as you want about questions that rise up today, so that we can answer to all of them. Our forum is actually pretty populated these days.
Yeah.
You say populated, it's crowded. So we've been using it a lot, and people seem to find it useful. So please feel free to join in.
So for example, regarding the question about the cumulative damage, you can open a thread there and put your own question. If you have some references or you know that you want to do something, you can post some references. We can look at them and place them somewhere in the future lessons. So yes.
There is a user of OpenSees Navigator who's asking if it is fully ready in modeling and analysis for various types of structures, if STKO is fully ready.
Yeah, actually STKO is interfaced with almost everything you have in OpenSees, also with things that you don't know are in OpenSees, because there are so many things in OpenSees that most of them are also not documented at all. So with STKO you can do a lot of things. If you just want to have an idea, because if I imagine from the question that you are really new to STKO, you can go on our website. There are some video presentations. You can show them some of them, so you can at least understand the capabilities that we have with STKO. You can look at our webinars. There are a lot of webinars starting from the very basics of a basic column model, going to micro modeling, soil structure interaction. So you can do a lot of things for sure. If you're a new user, just have a look at everything we have there. So for example, here are all the previous webinars.
Past OpenSees webinars.
Yeah, and this one is the syllabus of the new one. You can look at all of them. Each of them has a link to the YouTube channel, so you can look at the webinar. You can download the input files. You can try to replicate them. So at least you will have a nice idea of what you can do with STKO.
So we have plenty of them.
Yeah.
Already. So next question.
Okay, the link to the forum, Francesca. Okay, that one is Hannah.
When there is more than one element, do we need to transfer?
This one is, yeah.
Okay.
So let's shall go down,
Go down.
Down again.
Dr.
Okay.
Petracca.
I'm sorry if you're not. Actually, the lecture was given by
It's
Francesca.
okay, it's okay.
I'm sorry if I mistaken.
Model of infill wall.
Yeah, my question is about model of infill walls. I know in one of STKO webinar you explained a model for infill wall, which proposed by Mosalam. My question is there any generalized model or script which can be introduced in STKO where we can define different models and implement it in the generalized infill model? So basically, you are saying that you have your own infill model and you want to create a new extension inside STKO, is it right? Because if you want to do that, yeah, exactly. So if you want to do that, there are basically two approaches. First, I need to know if you created this new model as a C++ code inside OpenSees or not. Are you using only OpenSees existing components? Because if you're using components that are already in OpenSees, it will be very easy in STKO to create a Python interface that automatically does the infill for you. Okay, it's just about knowing Python, and you have to study a little bit of the Python API in STKO. Okay, so it will be very easy. The only automation for infill model that we have is the one proposed by Professor Mosalam. But if you have others, for example, I think maybe we chat in the past and you already told me about this, you were working on an infill model. So you can also open a thread on our forum, and if you have some experience with Python, we can guide you through the implementation of this. So it can be done, of course.
Dr. Nizar, if you want to open your mic and just like open up a conversation, like it's possible also.
Yeah, if you prefer to speak instead of
typing, because you.
Then we have another question. Lindsay Cohen.
No, we have a question about which is the option that we have to select to download OpenSees for this course. So, as we said, there's many procedures to download OpenSees. We have many on our website. The one that we suggest. I'm very happy that we met Professor Tucker because I say his name almost every week, but I've never seen his face. So it's the first one, download the unofficial versions compiled by Professor Tucker, which is an executable.
Yeah, it's much easier to install because
exactly.
it is just a Windows installer that takes care of installing all the OpenSees versions, sequential and parallel, and all the dependencies. Otherwise, you can go with the standard OpenSees implementation, but you have to take care of downloading TCL and making sure you have all the dependencies. So the first option, the one from Professor Tarke, is the easiest one for you. And you have the sequential and parallel version. So if you want to do analysis of large models, with that one, you're ready to go.
So there's another question about the new manual. Someone in Silhouette is asking, I'm not sure if I pronounce it correctly, if there will be a new manual since there's several differences in the current one. Yes, we are working on it. It's gonna be up there soon. We're gonna notify you when it is. We just had to update it with the latest version changelog and include everything else that is there.
Then there is a question from UA1. Hi UA. Will the design safe implement the same latest version of OpenSees?
Of STKO.
Of STKO? Yes, it will, but in the near future. We are working on it because we have to compile the latest version of STKO for their server, which is not a Windows, it's a Linux implementation, so we are still working on it. But yes, it will do it in the future, in the near future. Okay. So,
do you guys have
if you have any other questions?
We have a bit more time to dedicate to you. I'm sorry for everyone who got here a bit late. Maybe next time we're gonna give you like an academic 10 minutes or 15 before I start with this super short presentation. If you also have feedback or anything else you wish to learn, just like a wish list of OpenSees.
It's all the time. The academic 15 minutes, yeah. It's something that we have here in Italy. We need to be late.
So, hello, my name is Enrique Mares. I'm from TJ. just
Hello.
have a question regarding in your presentation that you have on the website. It's shown an element that has rebar. Are we going to be doing some modeling with rebar in this presentations?
If you are referring to the
sleep
bar, so the
yes.
micro model of the sleep bar,
Mm-hmm.
the detailed micro model.
Well, there's some animations on the website.
Yeah.
Wondering if
actually we have a course for that one. So if you are interested in that topic, we already gave a webinar for that.
okay.
It is already in our
you.
probably is the 14th webinar. It's the webinar about interactions. That kind of micro modeling, yes, is this one. Links and interaction between nodes and elements. So you can go there, you can watch the webinar, and you can download those input files. Okay, so you already have the input files for working with it. Here, I started with a simple model of just a column made with solids, and then with shells, and then with beams. And then at the end, I also shown how we can create more complex interaction, for example, with the steel rebars. I don't think it's going to be a program of this webinar course, because now this webinar course given by Francesca will focus on from the basic to the most advanced topic in OpenSees, but using frame elements. This one requires a better knowledge of OpenSees. So you can start looking at this webinar, and you can follow our general webinars on STKO and OpenSees. This one is more tailored for frame analysis.
So we're not going to model rebars like separately and inside the solid elements, but we're going to do fiber sections with rebars.
Okay.
So this one is a detailed model, a solid model of rebars explicitly modeled inside the solid domain of the concrete. There is also the bar slip interaction, so it's something more advanced. We are not going to cover micro modeling in this webinar series, okay?
It's a course. If you call it webinar, Professor
course series, yes. Course series.
So also modeling cinder blocks on it's a micro modeling concept.
Yeah, that is a micro modeling, because basically if you look at that webinar, you will see that I built the entire column as a solid. Then I created holes for the rebars. Then I put the rebars as fiber cross section in there, and then I created some special interaction for representing contact and bar slip. So it is actually a detailed micro model. Okay.
Okay.
So we are going to consider rebars.
Shells and bars will be implemented.
Exactly. Okay. Then we have another webinar on how to create shear walls using shells and plate rebars. So if you don't want to use the solids, you can use the shell implementation for shear walls. Instead, if you want to use a more basic approach, which is fine for frame elements, then this one is going to be a part of the Francesca's course, and it will be using fiber sections. Okay, so the standard approach.
Okay, thank you very much.
Welcome. Are you posting something? I don't know if you, no, I think you can just type something, but not the files.
Okay.
I think there is another question in the chat. Francesca, can you?
Yeah, there is another question.
Yeah, let me take the mouse.
As you know, nonlinear dynamic analysis needs, you can read it because the mic is next to you.
Okay, so as you know, nonlinear dynamic analysis needs convergence procedures, and in some cases, like blasting, it needs explicit methods. Please add some guidance or movie about explicit methods and convergence procedures in OpenSees, in STKO. We can do it not in this webinar course, because as I said, explicit methods are way more advanced, but we are going to cover something in the near future about explicit methods with STKO. We are actually now in the process of evaluating all the different explicit transient integrators that are in OpenSees, and we are trying to understand what are the best so that we can give some recommendation for that. If you go on our website and on our forum, there are already some users that are trying to use explicit methods in OpenSees. So you can find some guidelines there, because there was a user that was trying to model the collapse of a concrete building. For example, he was doing a model of a frame element, removing a column, and see how the collapse proceed. And that is on our forum, so you can go there and see the first recommendation that we gave him to understand how to start with explicit methods. Actually, I already gave a webinar on dynamic analysis in OpenSees, done with implicit and explicit methods, and I treated exactly as Hannah said. This one is the topic on our forum, but we also gave a webinar showing how to use explicit methods to model the blast, the simulation of a blast against a masonry wall. Okay, I think we have it here. Let me see.
Your turn.
Let me see if I can give you the link. Training, learning courses, and then there is one of the latest one. It was nonlinear time history analysis, which is the number. Where is that? 18. Nonlinear time history analysis. If you go here, I'm not sharing. Sorry. Let me just share my screen. Okay, if you go here, let me go. This is the webinar number 18. Okay. If you go here, I was explaining how to use dynamic analysis of a bridge using implicit dynamics, and then using explicit dynamics, doing something more complex on a masonry micro model of a wall, and using blast. Let me see, just show you the animation to see what can be done with the simulation. Here I was explaining how to create element removals. Okay. So this one is an explicit analysis using a blast load, okay? And as you can see in this webinar, I explained how to use explicit dynamic methods, how to use your custom TCL procedures to remove elements that are through certain damage criteria. For example, in my case, there were some mortar joints, and when their damage reaches a value which for me is a critical value, I remove them from OpenSees, so you can see all these pieces falling apart. So you can do a lot of things. The nice thing about OpenSees, as probably Francesca already told you, is that it is an open program. It is actually an interpreter, so you can put whatever you want there. And this one is a nice example, because here I actually coded my own code to recognize what are the elements that should be removed and how to remove them. Okay, so this one is a nice example if you want to learn something about explicit dynamics. Okay, stop sharing. So thank you, Ali, for this question.
Super difficult questions. So, anybody else has any question? I know we've been talking about advanced topics again, but if you also just want to ask how to export results from a script in STKO, we can talk about that, like whatever it is that you can find useful.
Or something that you want to do with OpenSees, but if you don't know if it can be done or how it should be done. So just ask about everything you need.
And thank you for the 5 people who still have their camera on. We appreciate it. Paolo, Said, Enrique, and who else is there? And yeah, Professor. Thank you, Enrique. Hi, Larissa. Okay, well,
I think
if there are no more questions, Thank you very much, Larissa. Thanks to you for participating. Oh,
Uh,
yes, hello. Why did you mention about steel structures?
Is there something in your syllabus? Not,
No,
but actually
so-
we can put something about do a parallelism between for steel structures, because actually once you understand, actually we decided reinforced concrete because for learning OpenSees is a little bit more complete in the sense that once you learn the steps, doing steel or reinforced concrete in OpenSees is the same, okay? So we are not here explaining how to design a steel frame, a steel structure, or how to design a reinforced concrete structure. Here it is about how to model it in OpenSees. And the same commands that you will use, for example, for fiber cross sections and reinforced concrete, you can use the exact same commands for steel models. Actually, it will be easier because you don't have rebars, you don't have all the problems of strain localization. So it's going to be easier actually. But steel shear wall, well, you can, as I said, if you want to do something special about shear models, like some special kind of shear walls, you can use the forum that Francesca showed before, and you can put your questions there. So we can see if it fits the topics of this course. We can put it somewhere in the yeah. For example, we can show how to use rotational approaches, how to use buckling for steel structures. So yes, just feel free. We try to prepare a basic syllabus of all the steps that we think that can lead you to understand how to use OpenSees. But if you feel free to propose other ideas like this one. So use the forum that Francesca showed you before to create your own proposals. Okay, we will try to put it in the syllabus so it can be a little bit more dynamic. So yes, we will insert something about steel structure there.
I've seen there's like a good 20%, 25% is left. Oh, there's another question. So, will parametric modeling will be covered in STKO Python API? We just did one.
Yeah, we just did it in the latest webinar was about parametric analysis using STKO Python API. I don't know if you're referring to that, because if you're referring to that, we just gave this webinar. I will show you. You can go on asdasoft.net. Once again, you go on training, e-learning courses. And then the latest one was about, actually the 20th and 21st are about the first two webinars about how to use Python API. And the latest one was about how to use the Python API to run parametric analysis, either with the sequential OpenSees or with the parallel OpenSees. So yes, you can do it. We will not cover it in this topic because during these months, I will be doing webinars using Python API. So I will cover those topics in those webinars, okay? So we are thinking of creating, I will go on with my webinars on advanced topics using customization like Python API for parametric analysis or for more complex analysis, while Francesca will keep this course for introducing people to the basics of OpenSees, okay?
There's Pedro who's asking about how to include contents, rigid bodies inside building.
Oh, rigid bodies, they can be included. Actually, there is not a rigid body element.
About the course, though. It's included in the course.
It is not included, but actually somehow it is included because the same concept for creating a rigid body is to use a kinematic constraint in OpenSees. So you create your own model and then you use a kinematic constraint to say that that body is actually rigid. And somehow you will understand how to do it, because when Francesca will get to the point of creating a structure, she will show you how to use, for example, rigid diaphragm. And once you learn how to use rigid diaphragm, you can use the same approach to create rigid links that I use to create rigid bodies, okay? So actually, it will be pretty straightforward.
You're welcome, Pedro. I mean, I didn't give the answer, but you're welcome.
You take credit for Massimo.
Yeah. Well, I mean, he took credit before because someone said thank you for the presentation. So maybe we can wrap it up today if you don't have any more questions. There's still like
hello. May I ask one question? Very simple, but I am a little bit confused. In OpenSees, actually, I am modeling infill wall, and I assign a truss element, and to that truss element, I'm assigning the material properties. So, is it the right way I'm doing? Because I'm a little bit confused on this.
I mean, your question is about if it is fine to assign an element material directly to the truss.
Yes, to the truss element. For example, if I assign a hysteretic material to truss element, because the truss, we know that the infill wall only take the compression load. So if I assign the hysteretic material property to truss element, will it be okay to model infill walls?
Yeah, I mean, it is okay, but it really depends on what you want to model about the infill walls, because infill walls, it's quite a large topic. For example, when you create when you simply refer to a truss along the diagonal direction with its own hysteretic model, that is fine, but the topic is how to understand what is the area of this truss, because not the entire infill wall will be reacting. It really depends on how the infill wall is connected with the frame around. Then there is also the topic about, do you want to consider or not the out of plane action, because if you model it with a truss, you will only consider the in-plane actions. So it is fine, but it really depends on what you want to model, okay? So if you just want to model the actual stiffness or actual behavior, even in nonlinear, of the infill wall, it is fine. What would be interesting is to try to find something that you can use to calibrate the parameters of this equivalent truss to make sure it represents properly the infill, okay? Guido? Share from Guido, yeah, there are many references for this kind of approach. So it is fine. The concept is that you model it with a truss if you want to use frame elements. The key point is to understand how to set up the parameters of the truss. So it's perfectly fine to use a truss and put the material there, but how do you calibrate what is the area of this truss and what are the values of the hysteretic model? That is the key point. So yes, it is fine. Oh, it is fine if you're only interested into the in-plane behavior of wall.
I think like we can also share with him our notes, like there are the description, exact description on how to develop the model using, because this was his question, using the behavior, using basically the truss model. So we can send it to him. Or we can even post it on the website.
Thank you, Professor Kamata. It will be very useful. Of course, yes, I am. If I know all the properties of truss, for example, the width of the infill and everything, and then if I am only interested in the in plane, then my question was regarding this. So
we will post it in this class. So
thank you, Professor.
So if you're only interested in the in-plane behavior, a truss is perfectly fine. There is no need to use a beam because you're not modeling the flexural contribution of the infill wall. So yes.
Thank you, Professor.
There is another question about Tonur.
About fluid structure interaction.
Yeah, actually, yeah, OpenSees has some fluid structure interaction with the PFEM model. Actually, at the moment, the PFEM is something that we have never tested with STKO. So we have to do some tests because we didn't receive any feedback on using fluid structure interaction. So you will be able probably to visualize some results, but there are no facilities inside STKO to create that model, okay? Probably we will look into this, but actually, as far as I can tell, you are the first person asking for fluid structure interaction now.
Massimo, what are you doing tonight?
Yeah, fluid structure interaction. Interfacing the PFAM with STKO.
Oh, there's someone in our waiting room still. People are like
Yeah.
coming out and in. Okay. So if there's some other questions, if you can just like maybe connect to your mics to post them if you want. Otherwise, I just wanted to tell you all that let's say now that you've signed up for the first webinar, you don't need to sign up for the next one, for the first class. You don't need to sign up for the next one because you will be just automatically invited to all of them. We will send you the email to participate. And we have another question in the chat. How to print, for example, load displacement curve.
Well, actually, we can. We have many in all the webinars that we have done. We always plotted the load displacement curve. And actually, in STKO, there is a facility to create a monitor that actually monitors a certain response during the analysis. Okay, so in real time. So if you look through our webinars, especially the latest one, you will see a lot of them. For example, if you look at the micro model of the out-of-plane behavior of masonry, I was tracking the load displacement curve in real time while the analysis was going. Probably when Francesca will reach the point of explaining nonlinear pushover analysis, for sure there you will see how to extrapolate the load displacement curve.
Yes.
Yeah. But if you want to know how to do it right now with STKO, look up any of our webinars, and there I will show you how to use the or even the latest one, for example. Let me show you.
Yes, sure.
Let me share my screen, and I will show you the latest one, the latest webinar.
Is this one?
No, is this one the latest one? Parametric analysis. Yes. Here I was set up in a. Let me see. Here it was at the beginning, and then I created a monitor that is actually able to monitor any kind of response. Is this one?
Sí.
Yeah, we have a monitor here that is able to monitor any kind of response. So here I was doing a dynamic analysis. I was monitoring displacement versus, oh, actually we have, at the end I did a static analysis. I was modeling the load versus reaction, the displacement versus reaction. Let me just find the point. Yeah, here I was showing how to set up everything, and then I was running an analysis and compare all the different pushover curves. Let me see, let me just find it. Okay. Here it is. So basically there is a tool that when you run OpenSees, now let me just wait for this. When you run OpenSees, when you run STKO, you have a monitor here that actually takes care of getting those values in real time while OpenSees is running. So just a second that the video reaches that point. Here we go. Okay, it is starting. So basically, I was starting OpenSees, and here the monitor pops up, and it is showing all the load displacement curves. In this case, it was even more complicated because I was monitoring the load displacement curve of 4 simultaneous analysis. Okay, so it can be done also with parametric analysis, and this is pretty straightforward. But as you can see, the monitor was displaying the load displacement curve in this case, while OpenSees was still running. So yes, you have many. Basically, I was using this tool in any kind of webinar, so pick just one and see how the monitor works.
Can I work with discrete elements in OpenSees?
Yeah, actually, It depends on what you mean for discrete elements, because I've seen a lot of people talking about discrete elements while they were still using finite elements, because the discrete element method is something else. But actually, you probably, if you want to do Masonry, you're just thinking about modeling the rigid blocks and the interactions between them. So yes, you can follow the same approach I did for Masonry micromodel, okay? But instead of assigning a nonlinear material to the bricks, where I was using the actual elastic properties of the bricks, you can just put a quite rigid elastic material, so you will achieve the same goal, okay? So you just lump the nonlinear kinematics, the nonlinear material properties inside the Masonry joints, okay? So there is no need to actually use a DEM method in that case. Discrete element method is used for other kind of stuff, but it can be done. So if you mean micromodel, where you explicitly model the particles, in this case the bricks and mortar, you can do it. If you really need the discrete element method, which is not the finite element method, that is not available in OpenSees. But I don't think you need them in this case. Material models for concrete. Okay, so what is your question? What do you need to know about material models for concrete?
If you want to turn on your cam and just ask the question, we'll be happy to answer it directly too.
Yeah, there are some.
Hi, can you hear me, please?
Yeah.
Yeah, thank you very much for the nice presentation. I have two questions to honest with you. The first one, that unfortunately I missed maybe the beginning of the presentation. Is there any opportunity that you put this presentation on maybe on YouTube or any other stage?
It will be on our website. We can show you where it will be, so you will be able to find it as soon as we upload it.
Okay, thank you very much.
So this is true for every webinar that we give and every course.
Yes, we will just upload the files.
You go under
on trainings, then here's a bit e-learning courses. Then we are here in the Get Started in OpenSees with STKO. And here you will have this button activated. Now, it's not activated yet, but
tomorrow,
tomorrow you will be able to click and find the presentation I gave and the support files I created for the presentation.
Okay.
For the link to the video. So yes.
Exactly. So you will be able to watch.
Thank you very much. Yeah.
Again.
Thank you very much. Thank you.
You're welcome, you say. Thank you for your question.
Yes, please. Thank you very much. And the question, thank you very much. Yeah, the second question, to be honest with you, is about maybe the concrete model. I have worked, to be honest with you, with the maybe concrete O1, concrete O2 in OpenSees, and maybe O4 and O7. But unfortunately, when using them for modeling, for example, the concrete column under heavy load, especially for the dynamic history analysis, maybe the only one could work and without any numerical issues, the concrete O1 and O2. Is there any improvement for the other models that you are aware of?
Actually, if you are talking about convergence issues, there are two key points. Some models in OpenSees, like the concrete CM, they are very difficult to converge because their hysteretic behavior is very complex. But keep in mind that every time you have softening, and this is true for concrete, you have convergence problems. So this one, I gave already a presentation about how to make the analysis converge during strain softening, which is not so easy. But actually we have another concrete material, which is the same we use for 3D, which is the damaged TC 3D. Then we have the 1D version, and that uses a specific integration algorithm that will always converge. I've been talking about the damaged TC 3D, but the 1D case is the same thing. So you can, we can show them the tester.
Yeah. Excuse me, are these models just within the STIA, or it is for the OpenSees
Well, the damaged TC is only available in the OpenSees version downloaded by Professor Tarke, because that is a DLL we created and we gave it to him, so it's not inside OpenSees. So only for the material model, yeah.
Okay, thank you very much.
You're welcome.
Just before everybody leaves, Hannah told me that the files are already online. So if you go where we said before that the button was not working, now it does. So you can download right now the material of the presentation of today.
And the video will be online instead.
And the video will be online tomorrow, just to show you what's inside. It's the presentation that I gave and the TCOS files. So here, there's like TCOS basics functions that I explained at the beginning, then the example of the fixed beam, then the example of the portal frame, and then the utility files to calculate your units. So this is all here. If you want to make one of the exercises that I posted, or anyway build one of your own, and you want to post it on our forum, please upload your file when you post the question, because we can help you better with the solution. And you have to put it in a zip format.
And by tomorrow, you will see also the link
video,
to the video presentation. We have something else on the chat. Oh, it's Nasir Ali. You're welcome, Nasir. Nizar. Yeah, probably it's dinner time. Yeah. So.
Yes. So thank you very much all for participating. We hope next time we can see more faces and hear more voices. Maybe we can, as we suggested, make a little bit of introduction at the beginning. Thank you, Isaac, for the laugh. And I'll see you all in a week. Next webinar is on, yes, Wednesday, the 5th of May. Have a good evening, morning, I don't know, wherever, whatever time zone you are. And thank you all.
Thank you, everyone.
Thank you.
The next lecture is just 5th of May.
Yes.
Thank you.
Thank you.
Thank you.
Thank you guys for participating.
Thanks.
Greetings to you.